What's up, steel maniacs? Today we're turning scrap into legend, forging a Wavy Damascus dagger from old bearing steel. Hit subscribe and let's bring this blade to life. First, let's turn these individual bearing races into one cohesive billet. We're stacking these 6 high-carbon rings and using a MIG welder to tack them together. Welding complete. Our goal is to create a solid mass of tough high-carbon steel for the core and eventually add softer, pattern-weldable steel for the rest of the blade. See how I welded a solid steel shaft to the side? Don't waste time making tongs for every single little piece. Just weld a temporary handle on, unless, of course, you enjoy burning the hair off your knuckles. Into the forge she goes. The goal here is the magical forge welding temperature, around 1200 and 1300 degrees Celsius, or a bright yellow-white heat. We need to reach plastic deformation territory. Alright, while the main billet cooks, let's deal with these other small cylindrical pieces. These are going to be the components for the handle. We're taking them one by one, heating them up, and then forging them into flat, paddle-like shapes. Notice how the metal is a bright, deep orange and yellow. If it goes too dark, it risks cracking under the hammer. Once forged, we toss it down and grab the next piece. Repetition is the name of the game here. We end up with a pile of these paddle shapes. See the one I painted red? That's just to mark it. Sometimes when you have several pieces of different steels, a simple paint mark lets you know what's what, even when you lose track. Now that we have the handle components roughly forged, they need a proper cleanup before we proceed. Time to clean up the scale and any messy edges from the forging process. We're mounting each piece in a large vise and using an angle grinder with a heavy-duty grinding disc. This removes the oxidized surface layer, the scale, and squares up the pieces so they're ready for the next forging session. You can't weld dirty steel, folks. Cut any excessive grinding footage to keep the pace. Now for the main Damascus billet. We're taking 8 of the clean, high-carbon bearing races and stacking them. We're using a clamp to hold the entire vertical stack together. Then, we weld on another handle, this time a longer, heftier piece of rebar, and run a weld bead around the entire perimeter of the stack. This creates an airtight container for forge welding. Back into the forge. Once it's glowing yellow-white, we sprinkle on the magic powder, borax. The flux melts, flows into the tiny gaps, and dissolves any remaining scale, creating that essential oxygen-free environment for the weld. A gentle hammer tap to seat it on the anvil, then immediately under the power hammer. We're flattening that round stack into a single, cohesive rectangular bar. That solid, welded chunk of steel we just made, it's about to be reborn. We fire it up to a glowing orange-yellow heat, soft enough to move but fierce enough to bite back. Under the power hammer, the bar stretches and thins, each strike forging it closer to the final shape. We alternate between flattening the sides and extending the length, controlling every hit, every spark, every breath. This is where brute force meets precision, the moment when raw steel starts to remember it's becoming a blade. Once it's roughly the size and shape we need, it's time for rough grinding again. We clamp the bar in the vise and clean up the surface with the grinder to remove scale and check for any welding flaws. We need a clean canvas for the next step, the wave pattern. I'm measuring the bar and marking out the handle section and where I want the wave cuts to go. We're using a marker and a small grinding disc as a template. Precision measuring in a blacksmith shop? Unheard of, but necessary if you don't want a wonky-looking sword. Using the angle grinder, we cut out the rough wave shape based on the markings. This is essentially creating the profile of the blade. Sparks fly, metal screams. This is just pure grit and steel. Next, let's create the base layer for a different pattern. We're taking 4 smaller square pieces of the same high-carbon steel, welding them into a square block, and adding a temporary handle. This block will be used to create a contrasting pattern for the guard and handle structure. The square block goes back into the forge, heated until it glows bright orange. We coat it generously with borax to protect the steel and prepare it for a strong compaction weld. Once it's heated and coated, we're ready to compress the layers together under the hammer. Under the power hammer it goes. We're compressing it to ensure the layers fuse completely, turning those 4 pieces into one dense, solid block. Wire brushing the hot steel between blows helps knock off any loose scale that could ruin the weld. To make sure you keep a secure grip for the rest of the forging process, weld the long rebar handle right onto the side of the hot block. It also ensures proper heat transfer. Back into the forge, back to heat, and under the power hammer we go. We're taking the now square block and drawing it out into a rectangular bar for the guard blank. This piece will eventually be cast as the brass guard. The forging process is done. We have our long wave-patterned Damascus blank and our smaller rectangular bars for the hilt fittings. Don't miss the next steps. Hit subscribe and follow along as we turn these pieces into a finished masterpiece. Now for the grinding and shaping stage. We mount the blade blank in the vise. We use an angle grinder with a flap disc to define the rough shape and grind the primary bevels. This process removes a significant amount of material, defining the cutting edge and the overall geometry of the wavy blade. Now for some pattern adjustment. I'm using a white marker to sketch out a secondary, more subtle wave pattern along the flat part of the blade's profile. We use the grinder to lightly engrave this secondary pattern onto the surface. We cut the main profile again, following the wavy line we drew. The blade's final shape is coming to life. Notice how the spine area is maintained for structure. Then, we grab a small, high-speed rotary tool with a grinding bit to clean up the internal corners and curves of the wavy profile. A final pass with the angle grinder to smooth out the transition areas and start the surface cleanup before heat treatment. We aim for at least a 120 grit finish at this stage to make sure any surface flaws are visible. The blade must be perfectly clean before we proceed to heat treating. Now for the most critical step, heat treatment. We heat the blade back up to its non-magnetic temperature, around 800 Fahrenheit to 840 degrees Celsius, a steady cherry red glow. We're carefully heating it to ensure the temperature is even throughout the blade. Uneven heating leads to warps. Quench time. We plunge the blade vertically into a tall tube of preheated engine oil. This is a fast quench, necessary for the high-carbon steel to transform into hard, brittle martensite. You get big, dramatic flames and a huge plume of smoke. The blade is now rock hard but brittle. We scrape off the burnt oil and scale with a file or steel wire brush. Next, it needs to be tempered at a much lower temperature, usually 200 to 250 degrees Celsius for a couple of hours, to relieve internal stresses and increase toughness. The pattern reveal. We need to expose the layers of the Damascus steel. We're using a tube of PVC pipe filled with a solution of ferric chloride, often mixed 1.3 with distilled water. We submerge and agitate the blade. After a few minutes, we pull it out, rinse, and gently scrub off the black oxides. We repeat until the wave and layered pattern is crisp and beautiful. Guard making. Sand casting. We're making the guard and pommel from brass. We start by placing a wooden pattern into a flask filled with foundry sand. The sand is packed firmly around the pattern. We fill a crucible with scrap brass pieces, old keys, plumbing fittings, and some flux to clean the surface. It's placed in a brick furnace fueled with oil to melt the brass, which has a melting point of about 930 degrees C. Carefully removing the crucible, we pour the molten, bright orange brass into the void left by the wooden pattern in the sand mold. We let it cool. Once cooled, we break open the sand. We now have our rough brass guard and pommel. We clean up the excess casting material, then use the grinder to smooth out the surface and start shaping the final curves. We drill and mill the tang hole and channel for the blade to fit perfectly. We're taking a solid piece of stabilized wood, cutting it to size, and drilling a deep channel to accommodate the blade's tang. We drill and chisel a rough opening in the handle blank that will fit over the tang tightly for stability. We dry fit the handle. The brass guard slides on, followed by the wooden grip, and then the pommel cap. Everything fits. Now for the final lockup, we use a 2-part epoxy resin, mix it well, and apply it to the tang, the inside of the handle, and the surfaces of the guard and pommel. We slide the parts together and screw the threaded pommel cap down tightly. Any excess epoxy is wiped away, and we let it cure completely. Once the epoxy is hard, the final shaping begins. We use belt grinders, sanding discs, and finally a bench buffer with polishing compound to smooth and polish the wooden handle and bring the brass fittings to a brilliant mirror shine. I'm squaring these rough brass fittings, working each surface patiently until the casting marks disappear and the geometry finally starts behaving. They came out of the mold uneven, full of small imperfections, so now it's a matter of slowly coaxing them into clean, reliable shapes. It's meticulous work, but this is the foundation the sword's hilt will rely on, so every stroke has to count. I clamp the brass securely under the drill press and begin carving out the tang slot, guiding the bit through the metal with steady pressure. This mortise needs to be perfectly aligned with the blade or nothing will fit during assembly, so I move slowly, checking depth and orientation as I go. It feels almost meditative. Me, the machine, and the awareness that precision here determines everything that follows. The end mills cut through the brass with that familiar steady grind, removing material layer by layer. I'm watching the walls of the mortise form clean, straight lines, adjusting angles when needed, and making sure the interior remains smooth. It's a careful balance of controlling the tool and letting it do the work. After every few passes, I stop to check the fit against the tang, making sure the slot isn't drifting or tapering. These constant checks might look excessive, but alignment here is everything. A millimeter off now becomes a visible flaw later. Each test fit shows me where to refine, where to correct, and whether the geometry is holding true. When the mortise finally reaches clean, consistent dimensions, I switch to smoothing the inner edges and cleaning the outer surfaces. The brass starts to look structured and intentional, instead of raw and unpredictable. It's satisfying watching the piece transition from rough casting to something precise and functional, ready to become part of the finished hilt. I continue widening the internal channel in the handle gradually, removing material carefully so the tang will seat cleanly without forcing it. Each pass is deliberate and precise. Too much weakens the structure, too little makes the fit unreliable, shaping the core of how the handle will perform. When the tang finally slides in smoothly, it's a moment of satisfaction, confirming that the internal geometry, wall straightness, and depth are all correct. After shaping and smoothing, I perform a final test fit. The tang sits straight, the alignment holds, and the handle supports the blade naturally, without twisting or forcing. I mix the two-part epoxy carefully, making sure the ratio is exact so the bond will be strong and durable. Then I apply it to the mortise, tang, guard, and pommel, ensuring full coverage. This adhesive is the structural core that keeps the hilt stable through every impact and movement. With the epoxy in place, I assemble the hilt, sliding on the guard and handle, threading the pommel down, and clamping everything perfectly straight. I inspect that all pieces sit flush and aligned, knowing that once the resin cures, these separate parts will become a single unified structure. I begin by grinding the assembled hilt, carefully shaping the wood and brass into the final ergonomic form. Every pass of the grinder is deliberate, refining curves and angles so the handle feels natural and balanced in the hand. Once the overall shape is established, I switch to sanding, smoothing the surfaces to remove tool marks and minor imperfections. I work through progressively finer grits, making sure every edge and contour transitions cleanly. Next, I prepare the brass for polishing, applying compound to the buffing wheel and carefully running the hilt across it. The goal is a mirror-like finish that not only looks impressive, but also highlights the craftsmanship of the piece. And there it is, the finished wave-patterned Damascus blade. From a pile of scrap-bearing races and some rebar, we've forged this incredible piece of working art. If you enjoyed this build, like, subscribe, and tell me what scrap metal I should turn into a weapon next. Thanks for watching, stay sharp, and I'll catch you next time.